Okay, now let's try and do some problems. All right, so we've got 3 freshmen and 1, 2, 3, 4 sophomores. Okay, let's see. The tutor schedules only 2 sophomores next week. What's the probability that Ginny's having a tutoring session? Okay, so I think we can do this by partition because really you're just choosing from the sophomores. And how would you split the sophomores or partition the sophomores so you guarantee Ginny's got a session? Well, you'd say, hey, Ginny, you stand over here. And then you other 3 sophomores, you stand over here. Okay, so if I want to choose out 2 sophomores and for sure pick Ginny, I will go over here and say, okay, out of this group, pick 1. So 1, choose 1. And over this group, pick out the other person. So that's me picking a winning group. If I didn't do any splitting, but I'm only picking sophomores, well, the tutor's only going to pick from those 4, and she's going to pick out 2 students. So that probability is 1 times 3 over 6, which is 1/2. You could do this one too by timesing. Well, let's imagine. Okay. So you walk up to the sophomores and you're going to pick 2. So first you pick Ginny, and then you would pick not Ginny. Then you need a multiplier because out of those 2, I want 1 to be Ginny. So the multiplier is 2. So 2 picking Ginny is 1/4, but then there's only 3 people left, and all of them are good picks. And so I get 1/2 here too. But the other way is way easier. And in fact, when I get to the next problem, I don't even know how I would do that without doing partitions or combinations. Okay, so let's see. They're going to schedule 3 sessions. No restrictions on who gets picked by class year, but I have to pick Ellie and Ginny. So how would you arrange the students to guarantee they get a pick? Well, I probably would make Ellie stand here. You could put them in the same group, but they're sisters. They don't like each other. So I'm going to separate. I got to pick Ellie. I got to pick Ginny. And then there's 5 people in the other group. Okay, so let's see. During the last week, you're going to get 3 sessions. So out of those 7 students, I'm going to choose out 3. That's just a random way to grab a group of 3. But I want to grab a particular group. So I'm going to go to Ellie. I'm going to pick her. 1, choose 1. I'm going to go to Ginny. I'm going to pick her. 1, choose 1. And then I'm going to go to the 5 remaining people, and I'm going to grab out 1. 5, choose 1. And so that turns out to be 1 times 1 times 5. And 7, choose 3 if you grab your calculator, is 35. So this probability is 1/7. Okay, now notice the next one. Take a second and read it. You need to turn off the tape. Go ahead. It's not asking for a probability. It's just like how many different ways. So this is just a counting problem. Hopefully you did lots of these last year. So I'm going to schedule 3 appointments for 1 week, but there's a restriction. I want 1 for freshmen and 2 for sophomores. So we can split them. Okay, you put the 3 freshmen in one group. You put the 4 sophomores in the other group. And then you just walk and grab them. So out of the freshman group, I want to choose out 1. Out of the sophomore group, I want to choose out 2. And since every way I pick the freshman, I can match with every way I pick the sophomore, I know it's timesing. 3 choose 1 is 3. 4 times 2, you could do it by hand, or I grabbed my calculator at 6. And that's 18. Okay, let's look at the last set of problems for today. And let's look at the difference, okay? For problem 2, there's 200 batteries, 3 of which are defective. So when you pick a defective battery, you change your chances of having a defective battery. So I know that this one is not binomial theorem. But for the second one, the chance of picking a defective one is always 5%. So I know that this one is binomial theorem and this one isn't. Okay, but for this one, I think we could separate them, right? There's 200 batteries, 3 of which are defective. So how would you group them? You'd put the defective batteries here, right? There'd be 3 of them. And you put the other batteries here, the ones that are good, the good ones, right? And I think if there's 200, 197 would be here. And let's see, we're going to choose out 5. And 1 of them is defective. Okay, so if I want to pick 1 defective battery, I'm going to go to my group of defectives. There's 3 and choose out 1. I'm going to go to my 197 good ones, and I've got to choose out the rest. So I think that's 4. And I'm going to divide it by the number of sets I could pick if I didn't have any restrictions. So that's 200, and I'm choosing out 5. So there's some kind of nice things to check. I'm going to grab the pen again. Okay. These together, since you've partitioned the set, that should match this number. Okay. And these are the numbers of total things you're picking. That should match this number. Okay, let's do one more. Okay, so this one we said is binomial theorem because you're picking and picking and picking 5 times, and we want the chances we get 1 defective. So our success is that we get a defective. So we've got 5% has to happen once, which means 95% has to happen 4 times. And then we need our counter. We're choosing something out of a group of 5 trials. So 5, choose 1. Okay, so now you've got your homework to work on, and we've got a little assessment feedback thing I'm going to try and work out for you. All right? Thanks for working hard.